Revati? Revati, can you unmute the name with Advay? Advay.
One second, sir. Both Shashwati, sir.
Shashwati as well as Harsha.
Harsha also, sir.
Yeah.
Co-host.
Okay, seems like
Harsha
I can
Vasudevan.
talk.
Yes, Harish. Good morning.
Hey, good morning, guys. How are you today?
Yeah, fine.
A very good morning, sir.
Yeah, welcome.
Make Shashwati as well as Harsha as co-host. Harsha Vasudev.
Ma'am, we made it, ma'am.
Okay. Harish, can you try to share the PPT?
Yeah, let me just quickly do that. Just give me a moment. So let me know if you can see my screen.
Yes, we can see the screen.
Awesome. Okay.
Yes. So, good morning, sir.
Good morning.
Just hold down. We will start at 11 o'clock. Inform all the students to join. And if it is above 300, you can ask them to join by YouTube link. We have already shared the YouTube link. Kindly circulate with the students.
Good morning, ma'am. Good morning, sir.
Good morning.
Good morning, my dear colleague and my dear student. Today we have Mr. Haris Haridasan sir with us. So I would like to extend a special welcome to our guest, Mr. Haris Haridasan sir, on behalf of Dayanand Sagar University School of Engineering, Bangalore. I want to convey my heartfelt gratitude to Mr. Haris Haridasan sir for accepting the invitation and presiding over this seminar on current trends in data communication and computer network. Mr. Haris Haridasan sir completed his BTech in IT and completed his MBA. He has 15 years of IT industry experience in HCL, Wipro, Microsoft, and currently he is working as a security product manager, cyber threat detection and response in Netherlands. He has many industry certifications like Certified Information Security Manager, Certified Ethical Hacker, Certified Hacker, and Forensic Investigator. He has networking experience of solution architect for designing and implementing the ONGC's 11 high network and security, solution architect for Dove Days Data Center, wireless LAN setup at RBI's headquarters at Mumbai, set up resilient layer 3 LAN for RBI data center. Now, I would like to invite Mr. Haris Haridasan sir to share your valuable knowledge with us. Please, sir.
Yeah, thanks, Shashwati, for that nice introduction. So at the onset, I really like to extend my heartfelt thanks to the faculty members of Dayanand Sagar University for inviting me over and giving me this opportunity to talk to students about the evolution of computer networks that we have seen. So I hope my voice is audible and clear, right?
Yes,
Yes,
sir.
Harish.
Clear.
Awesome. Okay, I'll get going then. In this session, I love to cover the evolution of computer networks, the genesis of computer network, how are we using the computer network in the present age, and what's some of the future trends that we are seeing in computer networks. So before I dive into that, I'll probably, let's see if I can click. Okay. So Sashwati definitely gave a good overview of my experience. So I really want to kind of present to you guys of how as a person in the industry can be helpful to folks in the academia and how we can prepare some of the folks to bring into the mainstream industry with much more preparation. So as you can see, I was part of engineering community. I came up from there, and then I got a good amount of industry experience, kind of wearing multiple hats. And I kind of started as a network engineer. So my domain was really in networking and hardware. And then over the period of time, I kind of progressed into multiple roles of different flavor. And then eventually, I'm currently working as a product manager for a big travel e-com company in Netherlands. So I'll probably love to share the anecdotes that I've gathered over the years of my experience, and hopefully this should be useful for all the students who are planning to get into or fancy themselves to be part of the IT industry in years to come, and may you have all the success. Cool. So I want to provide a bit of agenda, what we are going to cover through this session. However, I really want to emphasize that the key objective of this session is to sow the seed of interest in computer networks for you guys, because networking is a very interesting domain, but it also involves a lot of learning and understanding of very key concept, right? But for that, you definitely have your teachers to take care of that. My main objective would be to give you a sneak peek or peek into the network industry, like how exciting it is, and how I can make it really a good, interesting domain for you guys to jump in, if at all you plan to pursue computer networking as your mainstream career. So in the agenda, I'll be probably covering a bit of computer network history, some of the premise on which the modern computer networking is based upon, the key concept of OSI reference model and a TCP/IP model, some of the networking components that really makes up the modern age networking. And I'm a big fan of showing things in action. So I really want to show you guys how networking works in modern world. And hopefully this should really give you that excitement which I kind of gathered when I was an engineering graduate back in the days. And the last, definitely I want to spend some time in kind of discussing about the career options that we have in networking, and how you can prepare yourself to be industry ready if and whenever you plan to move into networking. So without further ado, I'll get going. So present day computer networks, right? So how important is computer network in the modern age? See, if you look into this picture that I've shown up here, it very well summarizes like how uh, network is so fundamental in our current modern age, right? Each aspect of human life is kind of interconnected to machines and various service utilities. Uh, I remember what I understand is this is an unprecedented time. Like nowhere in the history of mankind was human beings so connected with machines, and in the years to come, we are going to see this proliferation much more. So if you see here, like in earlier days, the communication was between two people, or from a person to a group of people. But of late, it has changed its medium, and now every aspect of our life is interconnected. Be it our houses, be it our wearables, be it our handheld devices like laptop, tablet, and we are also well connected with our services, right? Like if you have a package to be delivered, in real time we can track what is the progress of it, and when it's going to get delivered. We can also directly, hook into the IoT devices that we have nowadays, right? Like, we have like smart refrigerators, we have smart ACs, we have like smart houses, smart lightings. So how is that all possible, right? Like, you really need to, have these devices and things interconnected to make a communication possible. So as I was saying, computer networks plays a key role in kind of providing this impetus to the modern age communication. So a bit into the history of networking, you know. So back in the days when the computers were developed, right, its primary objective was to provide the computing power to make calculations easy. There was no concept of having two computers talk to one another. But some of the great minds had different thoughts. They really wanted to see like how they can harness the power of communication between two machines and then use it for humans' advantage. And that's when the actual research work started. So back in 1960s, packet switching concepts were like researched upon, because earlier it was mostly circuit-based switchings that were used for communication, especially for telecommunications, because back in the days people used to communicate using phones. There was no medium where machines can communicate. But circuit switching had its own drawbacks. It was not as fast as a computer needs to process the information. So it was a slow medium of technology. So to support computers to communicate, a different kind of technology needs to be looked upon. And that's where packet switching came into play. So with the advent of packet switching, also, some of the great minds, especially in the academia and as well in the US military, were thinking of how to connect the machines together, and they can have that communication get going. So the 1960s really set the fundamental stone of how this modern age computer networking can happen. So once the packet switching concepts flourished and the internet was kind of in fancy stage, people start getting curious, like, okay, how we can start using some of the services on top of this networking. That's where services like email were developed. So the first email was sent somewhere in 1971, and which was a giant leap in how machines would be used for modern age communication. Along with that, the Ethernet standard was a real game changer there. So it really standardized how computer networks can be connected to one another in a physical way. In 1978 till 1971 was really a key milestone time in computer networking. That's when the TCP/IP protocols were developed. And by 1981, the version 4 of TCP/IP was adopted as the primary communication protocol for computer networks. So when I say like this was important, was because this really set the standard of how machines can communicate with one another. Because prior to this, every university, every organization had different ways of computer communication. So when you have to communicate with a large number of computers, there was like large number of protocols, which was making it really hard. So when I say protocol, consider this equivalent to the languages that we speak. So let's say like if 10 people in the room are speaking different languages, then the communication is never going to be fluid, right? So that's where this was very phenomenal, because this really set that common language which computers can talk together. So this really opened up a plethora of opportunities of how different technologies and different computers can talk to one another. In 1980s and early 90s was really the time when the adoption grew like crazy. There was a lot of advancement into the switching technologies and routing technologies, which really made it possible for localized network to start communicating with networks outside their perimeter, and cross country communications start happening because of this. On top of it, it was also the time when the World Wide Web, which is known as WWW, also got birth, right? And this really enabled people to start using and connecting to internet to use the web services, which we currently know as all the websites and any kind of cloud services that we use. So this was kind of the genesis of that. So once we have like a good platform where the switching and networking can happen and the services are used, the next evolution was around how people can connect, or the devices which people have in their hands, like the laptops, the computers, the servers, how they can connect in a more seamless way to make use of these computer services. And that's where in 90s and 2000, the wireless technology really evolved. So prior to that, it was mostly radio technology that was used, but that was not very efficient for computer communication. So a lot of research had happened, and it resulted in the 802.11x standards, which we currently know as the wireless standards, which really enable a lot of handheld devices and modern age devices to be connected seamlessly with internet as we know today. And from 2000 till now, we have seen an evolution of how these cloud services, how this networking is really used to our advantage. So some of the key innovations that we have seen in this phase is Bluetooth, which really enabled close networking between devices. Cloud services, like how we really use the modern services to our advantage. Right now you really don't have to have too many storage on your local devices. You can have this storage available in cloud. You can have your computing done in cloud. All this data science, all this big data analytics that happens, you don't have to have the servers at your end. You can just have it in the cloud. It does the computation for you. And then all this is on the basis of the computer networks that are connected together. And the big boom came in the Internet of Technology area, which is the IoT. That's where all this proliferation of handheld devices, wearables, smart homes, smart technologies came into play. Because till then, till early days, it was mostly confined to laptop servers and machines, right? It was not beyond that. But IoT has really democratized how we use network and internet mainly for our disposal. So that really opened up a lot of opportunity. Um, so since we have talked about the history, now I want to deep dive into a bit of the premise of the modern age computer. Like, what are the pillars on which the modern age computer networking is based upon? And it cannot, go without discussing the OSI reference layer and the TCP model layer. So as I was talking earlier, communication is very key, right, in networking. So why do we network? We network because we need to communicate. We have some request and we need to get some response towards it. Now, to make that communication effective, it needs to follow a certain set of rules, right, which we call languages. That both the sender and the receiver should understand that language so that they can communicate effectively and in a fluid way. So similarly for computers, there should be a set of standardized rule that should enforce them so that they can talk in the same language. And that's where the OSI reference model and TCP/IP model comes into play. So in the early days, when the protocols were developed for network communication, there was not standardized approach to it. So OSI reference model, which actually stands for Open System Interconnect, is a theoretical reference model which was built up to standardize how computer network should communicate with one another. So as you can see, it has got a set of layers, namely 7 layers, which are highlighted here, which have different roles in network communication. So as I told earlier, like this is mostly a reference model. This never, was used as a practical means of communication. So what the network protocol developers did is they picked up the OSI reference model as a reference model, and then use that to develop the TCP/IP model, which is the current protocol stack which is used for all the modern age communication. So they took that reference model, abstracted that into the same ideologies, and kind of use that as a TCP/IP model, which we currently see in our modern age communication. So I'll spend some time on OSI reference model because this is a very fundamental concept that anybody and everybody who really want to get into the networking field should have a good handle on. So as you can see here, it has got a set of layers that are used to communicate effectively between computers, right? And this model is kind of implemented using firmware, which is the hardware code, as well as the operating system code. So it uses a combination of operating system and firmware to implement this in any communicating computer devices. So let's say, like, I take the example of my laptop, right? If I need to communicate my laptop to another machine, right? My laptop has a set of hardware, which includes the network card, the wireless adapter, and it has an operating system, which can be Windows, Linux, Mac. So in the combination of operating system and network, it facilitates my machine to effectively communicate with other machines or other services on internet. Now, digging a bit deep into this, I'll just spend some time on each layers, and then I'll probably show you this reference model in action in some time. So the first one is the application layer. So that's the layer where you talk to your computer, or you make your request to the computer, like what information you are requiring. So consider that application layer to be your browser, like Chrome, right? So whenever you have to search for something, or whenever you have to browse the internet, how you do that? You open a client, which can be Chrome, Firefox, or Mozilla. So once you do that, you type in, let's say, like www.google.com, right? Now you are presenting that information in a form that you understand. You really don't need to understand like how computer wants to process that data. So your layer is the application layer. That's where you tell the computer what you need. After that, the browser abstracts that information and translates that into a form which your computer stack can understand. So it kind of presents the data into the various data structures, After that, it kind of uses the session layer to manage the session between various communication, right? So because at any point of time, you might not be communicating to one particular website. You might be communicating to multiple website sites. So how the computer knows that which request goes to which server, and the response to that goes to which request. So that thing is managed in the session layer. Transport layer and the network layer are the layers which are responsible to route the traffic on the network. So this gives you some uniqueness into the communication that you're doing. So if I need to give an example, it's equivalent to the PIN number of our houses, okay, or the PIN number of our mailboxes. So it gives you, or it gives that communication that tag which tells us, okay, this is your unique identifier, this is your PIN number, and use this information to do that communication between two computers. And once we have all this done, now this data needs to be translated into a way which can be transmitted across our communication layers, which could be Ethernet, wireless, or it could be fiber. So how that translation happens is where the data link layer and the physical layer comes into play. They kind of encapsulates the data into packets, and then they translate that into bits in the physical layer, which is 1-0 binary bits, and then using electric signals or optic signals, they transfer the data over the network. So overall, this reference model tells you at a very high level how various protocols are in play to ensure that the communication which a sender wants to have with the receiver is consistent, and the receiver also understands the same language. So this kind of sets that understanding there. Now, as you can see, this seems to be a bit more complicated, right? It has got so many layers, so many complexities. So how it can be implemented in a easy fashion, and that's where the TCP/IP networking model comes into play. So what it does, it abstracts the practical elements of OSI reference model and translates that into 4 layers from 7, and makes it very easy for any network protocol stack developer to develop the protocol stack for communicating, right? So what it technically means is, let's say like tomorrow you want to develop an application, right, which needs to communicate over internet. So you really don't have to go through all these processes of developing those protocol stack. You have to just use some critical functions which are available, and making use of that, you can develop this protocol stack which has these elements. So you really don't have to have like 7 layers, but having only these 4 layers, which is namely application, transport, internet, and network interface, would really set your application to communicate with any services that you want to talk. So if somebody asks you like what is the difference between OSI and TCP/IP, in a very nutshell, OSI is a reference model, so it should always be used as a reference, and it would be always used as a reference model to develop any computer communication protocols. But the actual implementation of that is done through TCP/IP. So any network devices that we take today won't have like OSI reference model as a protocol stack. They will all be using the TCP/IP networking model as their communication stack. So that's a very key difference. Okay, so we have talked about the protocols, right? Like the rules which governs how we can communicate between computers. But for that protocol exchange, or for that communication to happen, you need to have some components which really facilitate how that conversation happens, right? So I really want to take you through some of the mediums that we really leverage to do this communication in modern age. So over here, you see 3 most commonly used mediums in current age of communication. One is the Ethernet cable. So the one that you're seeing here with 4 cable strips is nothing but copper wires, which are used to translate your information into electrical signals and transmit it over network. The next one is the wireless radio communication towers. So these are used for over long haul, but even for small networks, we have access points which has the same technology as what we see in radio towers. So they all use waves to communicate data from one place to another. And the last one, which is kind of the de facto standard for now for high data and throughput, is the optical fiber. So if I have to say, like, what is the difference between these three medium? So I can say that the Ethernet cables were the old technology, which is currently used also, but this is very good for setting up small networks, right? Like when you have a home or when you have a small office with 5 to 10 seats, you can make use of Ethernet, and you can use that as a shared networking medium. But it is not very good for long distance communication, and that's where radio and optical fiber really comes into play. So before the advent of optical fiber, it was mostly radio waves that were used for a long haul communication. But it had its own disadvantage. It required a line of sight. It was a lossy transmission mode where a lot of information was lost, a lot of noise was added to the transmission. So it was not a very effective transmission mode, but it was still the only option that can be used for long haul communication. But with the advent of optical fiber, it really improved the quality of communication, especially over the long hauls. Over long distances, we can have large amount of data sent with very little data losses. So one of the classic use case of optic fiber, especially in the internet backbone, is the optical cables that are laid between continents, right? So if you, I don't know how many but if continents needs to communicate with one another, they have a huge amount of optical cables laid between them in the deep sea, which kind of connects continents between themselves over internet. So whenever you try to access any resource from India to any resource in Europe, your data is actually traveling through sea and hitting the servers in Europe. So that's how this last mile connectivity plays in terms of the medium that we use. Apart from medium, there are some devices that also needs to support modern age communication, right? So these are some of the critical components that any networking folk should have a good understanding on. So here you see switch, right? So switch, as I said, packet switching is the fundamental concept of modern age networking. So it requires packets to be traversed over network. So how that is possible? So that is possible through switches. So once your information leaves your laptop or your handheld device, it needs to be routed over internet, right? So that's where switches comes into play, where it will translate those data packets into using switching. It uses data packets, and then it would send it to the router, where it gets routed to different networks across the world. So overall, the wireless access point is what you use to connect your home network to internet. And once you get connected to it, the data travels from a wireless access point to switch, and to switch to router, and then router to like multiple routers that we have on internet for that communication. All right. So as I told, like, here in a nutshell, you can see how data transmits from one host to another host. Okay, so on the left hand side, you can see a computer, a laptop, or a tablet, right? On the right hand side, you can assume that to be a server or a service that you want to consume. Or let's say, like, that's the server for google.com. So when on your machine you type www.google.com, it uses these data flow to translate the data into a form which can be understood by each layer. And then it kind of traverses this path of starting from host to the router to the server where this actual data is hosted. So here you can see the actual networking in action, like various layers are into play, and then the various components that we use are into play. And at the end of the day, when you try to communicate, you send a request from the host or from your laptop, and it goes to the server. Server receives it, processes it, and uses the same channel to send it back. So this should give you a good visualization of how data traverses in a theoretical way. I'll be probably spending some time to show you like how that is seen in action. So just hang on a bit more. So when you combine the protocols that we discussed, the networking components that we discussed, uh, the modern age network communication looks somewhat like this. Okay, so it is not just simple switches, routers, and TCP stack protocols, but it's a combination of lot of things that really makes what the current internet is all about. Okay, so if you see, like I'll take an example of this network, right? So here you have your laptop, you have your access point, and you need to have some let's say this is your university, and you need to access some data in your university. So how that is done? So you're sitting at home using your access point, you connect to your access point, right? And you are browsing your university's website. So how that actually comes into play in real life? Once you connect to this, your request is taken up. It is provided to your internet provider, right? It could be Act or Airtel or anybody. It goes there, right? So and then this internet provider will use a set of protocols, especially the domain name services, to identify, okay, like what is the website of your university, and get you the IP address of that. And then using the global routers, it will try to identify, okay, where exactly that IP address or that network resides. So these routers uses the DNS information, and it uses the routing protocols to route the traffic, and eventually it makes to your university. And within your university also, you have a set of interconnected systems, which could be your web server, the database server, and all they are connected. So in short, when the user makes a request, it traverses all this path to come and hit the web server, get the data from the database, and use the same channel to provide it back to the end user. So I'll show that in real scenario now. So let me just bring up something. So I'm using a tool known as Wireshark. It is a protocol analyzer. And as we know, communication is all about protocols, right? So you need to understand the protocols to see like how communication really happens, right? So as I was giving you the example, right? So let's say, like, I need to access a website, and show you how exactly the communication happens in the real world. So as a user, you go to a browser, and you let's say, like, I have this website to access, which is testingmcafesites.com. So how this really works is, let's say, like, I just clicked it gave me this page. So what you see is, you see that your request was made and you get this content back. You have not seen the magic behind the scenes, right? And that's what I'm going to show. So for any communication, right? So I went to this website, right? Now, how my computer knows that, where exactly is this website? So there should be some identifier that is going to tell me, like, okay, you have to use this address to go to this website, right? So how I am getting that? So all right. So if you see that I've used a set of command to get the address of this website. So the address of this website is 161.69.29.75. So this is something that I was telling earlier, like this thing, this set of numbers are known as IP address. This acts as a unique identifier which you would be using to communicate over internet, right? So you have your IP address, and the target web server will have its own IP address. So you have the address where you want to communicate. So once your machine has the address of this, right? Now it needs to communicate to that. So first he has to check, okay, whether this website is active or not. So how we'll test that? Okay, seems like there's some firewall blocking it, but I'll show you the example of what I really want to show you. So let's say like, okay. So this is what I really wanted to show. So for example, if the website is active and if the firewalls are not blocking it, you should ideally get a response like this, which says that, okay, I'm getting a reply from the web server. It is alive, so it is ready for any sort of communication. Now, to really show you like, what path my computer takes to communicate with this web server, so here what you're seeing in action is, this is my address. Okay, so it is showing you like, in order to reach to that website, what path on internet it is taking. Okay, so here it shows that it first reached to my access point. So this IP address belongs to my access point, and then it goes into my ISP, and from the ISP it kind of hits these internet routers to eventually lead to this IP address where the actual web server hosts. Okay, so if I really want to show it in a faster way, it might take some time. So this is a website that I know, like it's a website that provides electricity to our place. So this is would be much faster. So I needed to access this website, right? So if I need to show you guys like in the backend how this website is reached from my machine to that web server, it takes this path, which is it hits my access point first, then it goes to my ISP, it goes to additional internet routers. Eventually, it will reach to the web server where this is hosted. So this shows you like how, from your machine or from your laptop, it is trying to, reach to that server. So it really shows you the path that it takes. So this is the exciting thing that, really would get you going. Now, some of the things that I really want to show you at the protocol layer, right? How it really works if you want to get deep into it. So this is a communication trace that I collected when I tried to browse this website. So as I said initially, I made a request. So my computer made a request to a service known as DNS service and asked, okay, can I get the address of www.testingmcafesites.com? Then I got this response, okay, which said that the IP address of this. So here you see I have the IP address of my source machine, and this is the destination machine which responded to it. And it gave the IP address as, see this, 161.69.49.22. So as soon as you type your website name in the browser, the computer initiated this request, which is the domain name service request, to first get the IP address of that website. So once it had the website's address, it started communicating using the HTTP application layer protocol. So if you see here, like once I have the IP address, it will start making the conversation to that destination. So this is my IP address. This is the destination web server's IP address. And here, it made a request to the index page, which is the default page of that web server. And it asked, okay, get me the content of that page. The web server replied back to my host with the content of the web page. So here, if you see, this actually shows so the response actually captured the web page content. So this is the same content that you see here. So what I'm trying to emphasize here is when you type something in your browser, it was not transparent to you like what was happening underlying in your machine to make this communication possible. So it used a set of protocols to make that communication successful. So first it used something known as a DNS protocol, where it will try to find the name or the IP address of that particular website. And once it gets that IP address, it uses HTTP protocol to start communicating using that channel to the web server. Now, if I want to show you the practical implementation of a TCP/IP protocol stack that we were talking in my slide earlier, so you can find those protocols being clearly seen in action here. Okay, so let me just go back a bit to this. Okay, so let's say this is your machine and you made this request. So there is something like application layer, transport layer, network layer, and your physical access layer, right? So these are the layers that is typically used for modern communication, right? You can see the same thing in action here as well. So HTTP transfer protocol is nothing but your application layer protocol, which you really use to make that application layer communication with your website. So if I need to go, so this is your request which you have made. Now this request was taken by your computer, and then it started adding additional encapsulation to it to make it more machine understanding thing. So here, once the application data was generated, it encapsulated that data with these additional data at the transmission layer. So it will add things like which protocol to be used at the transmission layer, and what is the port on the web server that it needs to communicate. So if you see here, it shows that the destination port is port 80, which is the default port for web services, and it is using the protocol TCP. Okay, and it has like additional encapsulation information that you would be reading. So once you guys take the networking course in your semester, you will understand how these protocols are broken down into various headers and various fields that it uses. But just for the sake of this session, what I really want to highlight is consider that these are the components that make up this protocol. So technically, it will have the port information as well as it will have like which protocol it is using. In the Internet Protocol, which stands for the network protocol layer, is where you have the IP address or the addresses that I talked about, right? The pin number or the equivalent to pin numbers that is assigned to the packet. So this is where the computer would assign like, okay, what is the source IP address and what is the destination IP address that this computer should use for its communication. So these are like more or less happening at a higher level, and this is where things really get into the firmware or the network layer, and maybe like these are some of the things that you are studying right now. So this goes into the Ethernet layer, and it kind of encapsulates the physical hardware address of that. So if you see, this is known as MAC address, one which starts with C854-4B93B480. So this is nothing but the adapter's unique identifier, which is used for unique identification of network adapters. So this unique identifier is used when it needs to communicate at the lower layers of the protocol. And next one is the frame layer. So both the frame layer as well as the Ethernet layer forms this layer of communication, which is the link and the physical. So each of this layer captures what kind of flow we need to use, what kind of physical firmware is used, what kind of encapsulation, what kind of compression. All these details are captured in these two frames. So if somebody who really wants to get deep into these protocols, using a tool like Wireshark would really help us understand the protocol features and what attributes are used within each protocols. So what I really want to emphasize here is this really shows, like, the various components that really makes up at a very low level the communication that we really see in modern age. So for most of the people, it's completely transparent. They don't understand, like, what's happening in the background when they type www.google.com or facebook.com or any website that they're trying to access. In the back end, your machine is doing all this magic where it picks up that data, translates that into various protocol packages, and then transmit over any medium like Ethernet, fiber, or radio communication, and then provide it to tools or devices like routers and switches, which then move the packet from one place to another. So this should really help you in knowing, like, how a communication is made up of in the internet age. So I hope this at least gave you some clarity of how networking looks like. Now, to share you some anecdotes from my engineering days, how I really got hooked into networking was, this curiosity, like, how a machine can communicate to another machine, right? So back in the days when we used to go to computer labs, most of my colleagues, they were like more keen on doing the programming and code, but I was not one of those. My thing was like, how these computers communicate and how we can do silly things using computers. And in the labs, what we used to do is that back in the days, there used to be a protocol supported by network, which was called NetUse. And using that, we can send messages to one another. So during the lab times, what we typically do is we just use NetUse and try to talk to one another, even though like we were sitting far apart. So that was like really interesting. And then after that, we really started getting into some nasty things that we can do with computers, right? So I can literally shut down the computer of my colleague sitting very far from his desk. So those things really got me hooked into the fascinating world of networking. And even though like initially it was really nice because I really felt that, okay, this is something really interesting. But then soon I realized that in order to have a good sound understanding of networking, I really need to do a bit more learning and understanding of how things really work. So if anybody who is really keen on going further into computer networks, and I'm sure there would be people because you are students of computer science, and maybe some of you guys would really want to get into designing computer systems, and networking is a very key component of it. So if some of you are really keen on pursuing in computer networks, then my suggestion, as a person who has spent some time in industry and who has really started his career in networking, is to be curious. Be curious, like how things happen. You really don't have to stick to the de facto. It just happens. Don't buy that. Be curious and try to understand like how that happens. Try to understand the fundamentals of computer networks. And I believe your teachers would be doing a great job in kind of taking you some of the very low level stuff that really makes up computer networks. So, what are the various layouts? What are the various types of networks that you use? And maybe, going deep dive into the OSI layers that we just discussed. So have a good understanding of the computer networks. There is a good book that is written by Andrew Tenenbaum, which is known as Computer Networks. So if you guys can get hold of that in your library, or you can purchase it from Amazon or Flipkart, that would be a good investment. It would really give you a good understanding of how the modern network is built upon. Have a good understanding of the TCP/IP model, the various protocols that we use to communicate between within this model, and use a tool like Wireshark or any open source protocol analyzer, and try to analyze and relate your knowledge of those protocols back into, like, how those protocols look like in real implementation, right? So I talked about DNS protocol, right? So DNS protocol is a protocol that is used to identify the IP address or the unique address of a particular web address, right? So it follows its own set of rules to make that communication. It just cannot, follow the rules of HTTP protocol to do that communication. It follows a set of rules. So read about that rules, read about the headers that goes into it, read about the encapsulation that it goes into it, and then use a tool like Wireshark to understand it, right? So if you see, like, this is the format of its query, and this is the format of its response. So how that is made up of would really help you to correlate between what you have learned and what happens in real world. And this really be useful to you guys. And apart from, learning and reading about all this, try to do practicals. I'm not sure, like, how much your computer lab facilitates, but if they don't have like networking workshops, where you can, create your own small network setup, between your own members, you can create a local network of laptops. Your access points are very cheap now, so you can buy a cheap access point, or even network switches, like 4-port switches, and then try to, see how you connect it, how you give IP address to them, how you communicate to one another, and then try to, connect that to your internet access router, see how that communication goes, take some packet capture, analyze them, and use, all the knowledge that you have gained through your reading and your studies, and then apply that as a practical workshop. That really helps. For me, that really helped, because I used to do that. I used to, come back to my room. I had like few friends. We had our laptops and computers connected, and we used to do all sort of, silly things to see how this networking work. So this would really help you, and I suggest, like, most of the folks to, kind of invest time here. But if you want to take it to the next level and really want to be, industry ready, so apart from the knowledge that you gain from your self-learning, I would highly recommend to take some industry certifications around networking. Cisco is a very big vendor in internet routing. It builds and develops a lot of internet-based switches, routers, and other networking gears. So they provide a set of training path which prepares people for industry. So it has like various certification path, like CCNA, which stands for network Cisco Certified Network Associate. Then it goes into CCNP, which is Cisco Certified Network Professional. And then eventually, like, once you have gained sufficient knowledge and become more proficient, it goes to the next level where, you can apply for the CCI, which is the Cisco Certified Internet Networking Expert. So it really goes into that experting level. So if somebody really wants to, pursue the network as a career, I suggest at least to get the CCNA done, and if you want to take it a bit higher, at least get the CCNP also done. So that will really get you industry ready to pick up any job roles that are there in industry. Which takes me to the next slide. What are the career opportunities that you have? Okay. So if you really want to go into the coding piece of it, and really want to get into the protocol stack development, then you can use both your ability to code as well as your understanding of a network to get into the network protocol developer or tester. It's a huge demand for people to get into this. Cisco does a huge hiring in this space. Then the next one is a bit generic role, where if you don't want to get into the development of protocols, You can always become network engineer, where you would be building up networks. You will be setting up networks for big organizations, big, small, any organizations. Even in universities, network engineers are employed. So network engineers seems to be the most common path which one takes once it gets out of the college. So you can really start off as a network engineer. And after having a good experience of how network works in the practical world, setting up few network on your own, then you can move into the network consulting and architecture roles, where you would be consulting folks how to set up their networks. So it's also a very well-paid job. So once you gain your knowledge, you can really use that to build and implement networks. Network architecture takes you to a completely different level, where you would be start designing bigger networks. Let's say like you have a university, right, that's coming up. So you really want to connect the entire university with the other universities, and have a big network, right? So that requires somebody with a good architecture knowledge to build that plan, how it would be connected, and lay that out so that network engineers can actually implement that in reality. So it's also a good career path if somebody wants to take that. Uh, After that, it kind of really gets into, so network architecture and network expert is where you would be like growing in the technical space. But after a certain point of time, if you think that, okay, I've done enough, so maybe I have to maybe overseeing how things are done in network space. For example, after the network architecture is designing it, but the overall program of building a network is the main thing. Then you can also go into the roles of program manager or product manager, where you would be working with network architecture, network consultants, and various vendors, and come out with this plan of how to get a network implemented, and then work with all these stakeholders to get that as a reality. So this is an interesting role, where not only you would be technically sound, but also it will help you with your organizational skills, your communication skills. So if somebody is really fancying themselves to be in this space, this is a good role to take up. Last but not the least is academia, right? Unfortunately, I don't have many friends except Rija and few other folks who are really, giving it back to the student community. We are more into providing a value and services to the IT industry, but we never get a chance to give it back to the academia. So if somebody wants to really use their knowledge and skill, they can always go back and provide that through being a professor or a lecturer, or in some case the dean of that university. So academia is also a good option, provided it kind of you have that craving of giving it back to the student community. So at a high level, these are some of the roles that can really be seen as a career opportunity if you guys are planning to look yourself in the networking field. Yeah, I think I did a lot of talking, so maybe I'll give the floor to the folks in the house to have some questions.
Yeah. Thank you, Harish, for the inspirational talk. He narrated the details about career development as well as career opportunities in computer networks. Dear students, if you have any doubts, kindly ask, or you can put it in chat window. Any doubts? You can put it in chat window.
I think somebody raised hand, so let's.
We cannot unmute, but you can put it in chat window. And fill the Google form. You have feedback forms is put up on the chat window. Just fill the Google form without fail. As well as that this webinar is a part of CAA component data communication course. Submit the reflection note by today 3 p.m. Late submission is not considered. Again, the feedback form response will be open for 10 minutes. Yeah, Arpita, kindly make open for response. Yeah, now it's open. Fill the Google form. If you have any doubt, kindly ask. Otherwise, we will close the session. Yeah, one question we have by Satvik NG. Why are the presentation layer and session layer not needed in the case of TCP/IP?
Yeah, I think that's a good question, and I'll probably go back to the slide. All right. So it's not like it's not needed. What they have done is they have abstracted the presentation and session layer within the application layer. Okay. So when the OSI reference model was built, it kind of separated out the application layer, the presentation layer, and session layer in different forms. But when the TCP/IP model adopted that section, what it did was it just abstracted application, presentation, and session layer into a single application layer. So in TCP/IP model, when it is actually implemented in your code, all these three layering happens within the application layer. So it's not like they have discounted any layers from the OSI layer. What they have done is, just for the simplicity's sake, they have combined multiple layers into one, but they still keep the layers that is called out or highlighted in OSI layer. So the presentation and the session layering still happens in TCP/IP, but it happens within the application layer.
Thank you, Satvik. And one more question from Tenzin.
Mm-hmm.
Is there any way to regulate .onion? How are they different from VPN? Okay,
very good question. So Onion network. So for others who doesn't know Onion network, so in internet, in open internet, right? When we talk, right, we know, like, which are the endpoints that we are communicating, and I did show it here. Let me just, yeah. So if you see here, right, when I did a trace route to an end server, which I want to communicate with, I know like which IP addresses it is traversing through, right? So I know, these endpoints. But when you use something known as Onion network, it is kind of making your communication anonymous. So you really can't track like who is talking to you. So neither the sender nor the receiver knows, like, the real IP address of both the folks. So this is primarily used as a way to bypass control. Okay, so for example, if somebody in China wants to access Facebook, which is kind of blocked by their firewall, so they can really make use of this Onion networks to bypass those controls and anonymously access your those blocked or unauthorized websites. Now, Onion network is formed as part of an hacktivist movement where how do I put it? Like, it's kind of a rebel network, and it's very difficult to regulate because it happens mostly in that space of network which is not government regulated. So when we say internet, it has its own set of parties who kind of regulate internet. So there are certain bodies who kind of enforces the internet service provider to ensure that they provide transparent information. But there are a set of other internet service provider who doesn't disclose this information to third party, because of which tracking or regulating the Onion network really becomes difficult. So I would be very careful in using Onion network because even though it says that people cannot trace you back, but the NSA of US has actually hacked into the Onion network because they really want to track like the criminal activities, because Onion network is predominantly used for nefarious activities also. So if at all, if somebody is using Onion network, chances are there that you might be, maybe like, the cyber cops would be at your tails. So be very careful in using Onion network. And to the question, where it was asked, like, what is the difference between VPN and Onion network? So VPN is a technology that we use to connect remotely, right? So if, for example, I'm working from home for past 1 year and I still need to connect to my office network, right? So since I'm not in office, I cannot, physically connect to my office network. So how I can connect? So the only way I can connect to my office network is over internet. Okay. Now, internet is not safe, right? People can hijack my communication. So to ensure that there is a secure communication between my laptop and my office network, we use a technology called as virtual private network, where the conversation between my network and my network is encrypted, okay, over internet. So the communication still happens over internet, but the channel is completely encrypted. So even if some attacker tries to sniff in my data, they won't get anything. It will all be garbled data for them. So that's where the VPN comes into play. So in nutshell, VPN networks enable people to connect to their private networks. Onion network is done to bypass restrictions, and if you want to anonymize your activities of you don't want anybody to trace you back, you can use Onion network for that. Hope I was able to answer the question.
Thank you, Tenzin. Any other question? Yeah, one more question from Sati.
Sure.
Can we set up a virtual network terminal to remotely host something on the network and make use of network completely anonymous?
Not sure I followed this question correctly, but when I talk about so what I understand is what he's trying to uh, ask is how different is this from the Onion network? Because Onion network literally uses the same concept of a VPN, which is your encrypted communications. But here it kind of goes through multiple layers of something known as Onion routers, which would really make the conversation anonymous. Okay, so even though the conversation is still encrypted, like you are really talking on a one-to-one channel with the receiver, however, the receiver nor the sender would know the actual identity of one another. So I don't know, like there are codes for setting up Onion network. So if you want to set up a small Onion network on your own, there are codes to do that, but it really requires more networking power to really set up a big Onion router, and it is traditionally done by internet service providers. It would be very difficult to set up your own Onion network with it. You can still try, like I can probably share you the code for Onion routers. If it's possible, you can try that out. But yeah, it may not be an easy thing to do.
Yes, we will collect the presentation and the details from the resource person, and I will share you the details. Okay, we'll wind up the session. I would like to call Dr. Harsha to give vote of thanks.
Thank you, ma'am. Ma'am, am I audible?
Yes, Harsha.
Okay, thank you, ma'am. On behalf of our department, I, Dr. Harsha Vasudev, Assistant Professor, Department of CSE, express my heartfelt thanks to our resource person, Mr. Harish Haridasan, for the great effort and valuable inputs on the topic, current trends in data communication and computer networks. Sir, it was such an amazing talk, sir. You have covered both the theoretical and practical angle. Thanks a lot, sir. Then I would like to extend my sincere thanks to Dr. Sanjay sir, Chairman, Department of CSE, and our webinar organizer, Dr. Rija ma'am, and all the coordinators, Dr. Revati ma'am, Muhammad Imtiaz sir, then Dr. Shashwati, Professor Nantini, Professor Renuka, Professor Arpita, for their valuable support. Also, I would like to extend my thanks to my colleagues, last but not the least, our 5th SEM students and other students for their cooperation. Once again, I thank one and all here. Thank you all.
Yeah, thanks a lot for that. And as a closing note, I really want to, thanks once again to everyone who has invited me for this call. Hopefully, I was able to provide little value back to the student community, and hopefully, I was able to at least have some flicker of inspiration for you guys to take computer networks as something that you really want to do down the line. Um, so yeah, I'll be sharing the deck. It has my LinkedIn profile. So if somebody wants to connect with me, have any queries about or need any career guidance, or really wants to talk anything about networking, I'll be all the more glad to help you guys. And I'm really happy that I got this opportunity to talk back to the community. So really glad. Thanks again.
Yeah, thank you, Harish. Thank you so much for spending time with us. And again, students, again, I'm telling that you have to submit your reflection note by today, 3 p.m. Okay, we will not consider the late submission. It's a part of CAA. Today is the last day to enter the CAA marks. Okay, thank you all.
Thanks all. Wish you good luck.
Yeah, thank you, Harish.
Thank you.
Yeah, welcome. Cheers. Bye.
Bye.